Good morning, boys and girls. I'm sorry that I'm not with you this morning, but this morning we're going to look at several videos on how to do related rates. Related rates is used to look at how things change with respect to time. It is a very important subject in calculus, and it's one of those subjects that you're going to perhaps not be your favorite in the beginning, but after you do several problems, I hope that you'll understand it and that you'll get it. We're going to start today with some very simple problems, and when I come back on Monday, then we will dive a little bit deeper. We're going to start with some simple problems this morning, and I just ask that you watch each of the example videos, take notes, and then try some on your own. And again, when I get back to school on Monday, we'll go over this some more. Okay? So generally, in a related rates problem, you're going to be asked to find one variable in respect to time, and we call that dx dt. If you recall from yesterday, we did implicit differentiation. So remember, when we're taking the derivative of x with respect to time, it is now dx dt. Or if we're taking the derivative with respect to y, it is dy dt. It is the derivative with respect to time. So when we have a quantity similar to 6x that you see here, normally that derivative is just 6. But when we're taking the derivative with respect to time, it becomes 6 times the derivative of x with respect to time, or 6 dx dt. So here's an example. You're given that dx dt is 2 units per second, and you're trying to find dy dt. So we were given the value of y, so we're going to start by taking this y and taking it with respect to t. So the derivative of y with respect to t, we would write that as dy dt, the derivative of y with respect to t. To find the derivative of 3x squared, we find the derivative of 3x squared like we did before, which would be 6x using the power rule. And then we find the derivative of x, which would be dx dt. Now we're using chain rule. That would be, once again, we've talked about this, 6x, the derivative of that is 6. But since we're taking the derivative with respect to t, it would be 6 dx dt. Okay? So since we're trying to find dy dt, we have to find the values that we need to plug in here. So if you can see that we have the value of dx dt, what is the value of x? Well, it says find the derivative when the particle is at the origin. So if the particle is at the origin, it has an order pair of 0, 0, meaning that x is 0. So I'm going to do dy dt is equal to 6. X in this case is 0. Dx dt is 2 minus 6, once again, times dx dt, which is 2. So we get dy dt is equal to negative 12, and units are important, so we're going to say this is units per second, because the only quantity that we multiply by was 2, and the 2 is units per second. Here are a few strategies for solving related rates problems. The first thing you want to do is absolutely read the problem carefully. Most of our problems we will use Pythagorean theorem, but sometimes we will use the area of a circle or a cone or a cylinder. So you want to draw a diagram if possible. You want to introduce notation. So you want to say, okay, so this quantity is represented by x and this quantity is represented by y. We have to look to see what are we trying to find. So if we're trying to find how fast y is moving, then we would call it dy dt. If we're trying to figure out how fast x is moving, then we call it dx dt. So we have to express the given information in terms of derivatives. We're going to write an equation that relates the quantities. So we may use Pythagorean theorem, we may use the area of a circle, we may use the area of a cone. Then once we have that, we're going to differentiate with respect to t. This is important, and this is where most students make their mistakes, is forgetting to differentiate with respect to t. Then once we've done all our deriving, then we're just going to simply substitute information in and find an answer. We're going to do lots of problems, so please don't get fearful now. And I ask you to watch all of the examples before you begin trying to solve problems. So please watch example 2 next. Thank you and have a great morning.